In this video, we're going to look at a Faraday's law problem in which we're solving for mass. So our problem is what mass of copper will be plated from a copper 2+ solution if 10 amps of current is applied for 2.5 hours. So our first step in solving this problem is to write down our half reaction. So copper 2+, that's our copper 2 ion, is going to gain 2 electrons to form solid copper. So that means that we have a 2-to-1 mole ratio between our electrons and our copper. Now we're going to get started on the actual problem solving. So our first step is going to be to turn that current and the time into the charge. So I'm going to do this in one line, but I'll break down what I'm doing in each step. So an amp is really a coulomb per unit per second. So 10 amps can be written as 10 coulombs per second. 2.5 hours is really 9,000 seconds because there's 3,600 seconds in 1 hour. So at this point, our seconds will cancel and we are left with coulombs. So we've calculated the amount of charge that's been added to our system. Next up, we're going to turn that into moles of electrons using Faraday's constant. So we know that 1 mole of electron carries a charge of 96,500 coulombs. This constant can be found on page 3 of your Chemistry 30 data booklet. So now we've turned that coulombs into moles of electrons. Our next step is going to be to convert that into moles of copper. Because we're interested in the mass of copper, we need to get to moles of copper. So we know that for every 1 mole of copper that we form, 2 moles of electrons have been gained. So that's from our half reaction. At this stage, we've now solved for the moles of copper. And lastly, when we're trying to solve for mass, we're going to use our molar mass. So we know that there's 63.55 grams of copper in 1 mole. So at this stage, we've now solved for grams of copper. And our units will cancel such that we're left with only grams. And our final answer, we get 3 significant digits. So we're going to have 29.6 grams of copper.